All right, hi guys. Just working on going over some of the things you'll have to do for this week. So that first section of homework, which was 3D, we get into measures of dispersion. Measures of dispersion are how spread out the data is. So the basic one you're already familiar with is range, where you subtract the smallest number from the largest number, or your max minus your min. The one you're less familiar with is standard deviation. We will use sigma. That's that lowercase letter right there. It's a lowercase sigma. So you're probably familiar with the uppercase, which looks like an E that we use for summation. This one is a lowercase sigma x. It stands for standard deviation. Standard deviation lets us understand how far our data is from our mean. So essentially how spread out our data is. We have this formula here. It looks a little bit scary, but most of the time we will use this with technology. You will not have to calculate standard deviation by hand. So if you see this in examinations, you will use technology. So basically anywhere outside of maybe your IA, if you use statistics, outside of that, you will not have to do any of this by hand. So I'll get you started and show you what that would look like. So if we're using investigation 4, that's in your chapter 3 work, and we want to compare these sets of data, right? We have a set of girl scores for a quiz that has 10 questions and how many they got correct, and we have 10 boys scores for how many they got correct. So the way to set this up with standard deviation, to do this with the formula, we have the next, if we go to the next page, right, it has the girls' mean, or the girls' score minus the girls' mean, and then the boys' score minus the boys' mean, and then we square each, add them up to get that piece of our formula. So if I go back up here, this is the formula we're filling out, right? X minus the mean squared, find the sum, divide it by the number of terms, and then square root it. So I'll show you kind of what that looks like if we start to do this by hand. So if I do the girls first, we have the girls' scores, which is 2, 3, 4, 5, 5, 6, 8, 8, 9, 10. Okay. The next piece we need is the mean. So we have our data. The next piece we need to do is the x minus x bar, which is your mean. So first I have to calculate the mean. So if I add all of these together, right, so we have 2 plus 3 plus 4 plus 5, etc. We get a total of 60 divided by the number of terms. We had 10, so that will give us 6. That means the mean for this data is 6. Bear with me. So the next column, we have x minus the mean. So that means each data point minus the mean. So this one would be 2 minus 6, which is negative 4. And then 3 minus 6, which is negative 3. And then 4 minus 6, which is negative 2, etc. So I'm just going to run through the rest of these. And that would be the difference, right, in my data point and the mean. The next piece of this formula is squaring them. So it's the differences or the deviations squared. So I'm going to take that column and square it. So in this case, negative 4 squared is 16. Negative 3 squared is 9, etc. So negative 2 squared would be 4. Negative 1 squared is 1. 0 squared is 0, 2 squared is 4, etc. Okay, so then I have all of my squared deviations. Okay, the next piece of the formula is sigma. What this means is from my starting value, so from my first term all the way until my last term, so in this case the 10th term, I'm adding all of those up. If you do this in a chart, that means all of this column we are adding together, right? Because we're finding the sum. So if I add all these terms together, I get a sum of 64. And of that sum, the next piece is dividing by n, or multiplying by 1 over n. So n in this case, n is your number of terms. And remember, we had 10 terms for this. So we would take our 64 and divide it by 10. That gives us 6.4. This number is what's called the variance for the data. Sorry, you can't see that. So once we divide it, when we're inside the square root, that's what we call the variance. And then we square root that to get our standard deviation. So I would square root 6.4. And if I do that, I get approximately 2.5298, etc., or 2.53 as our standard deviation. Okay, what that number means is we tie this back into the context of the problem. So since we were talking about the questions correct out of 10, that means on average for the girls, they are scoring 2.53 questions on average from the mean, which our mean was 6. Okay, so on average for our data, the girls were scoring 2.43 questions above or below the mean. That's what that means for the chart to do this by hand. Now, to do this in the calculator, it's quite a bit easier. We're going to go to your list, so you hit Stat, and we want to edit the list, so hit Enter. And then whatever's in my list, I'm going to go ahead and clear out. So I'm going to hit List 1, always hit Clear, never delete, always clear in the list, and then Enter. L1, since we have all of our data, that's where I'm going to put all of my terms. So for the girls' data here, I'm going to put all of those values that I had to begin with. So I have 2, 3, 4, 2 5s, etc., until I have all of my data. I would always go back through and check. So since I had 10 terms, if you see this L and the place value, so L1 position 10, right? I had 10 terms, so I have 10, 9, 8, 8, 6, 5, 5, 4, 3, 2. I have the same number of terms in the right order that I had my data. From here, it will calculate my standard deviation on its own. So I can do stat, calc. We have one variable, right? All of our numbers, all of our pieces of data is representing one thing. So like questions answered correctly. So one variable, statistics. All of my data is in list 1. I don't have a frequency list because all of my data is in list 1. And then we calculate. So what this will give me is we have a mean. So x bar is the mean, which is 6, which is what we got down here by hand, right, when we calculated that earlier. N is our number of terms, so that was 10. Standard deviation, again, is the sigma x. So here it is 2.529, etc., which 2.53 to 3 sig figs is what we got. The other thing this will give you is your 5-number summary. So when we get into outliers and things next, you have your minimum value, your Q1 or your quartile 1, your median. Notice it's 5.5 because we had 10 terms, so that median would be between two numbers. In this case, the median is between 5 and 6, so 5.5 is your average, your Q3, or your third quartile, and your maximum number. We'll need this when we get to outliers, but I'll explain that in another video. Okay, but that's how you get started with standard deviation, both by hand or doing it in the calculator.